Hai semua. Previously, I've talked about a type of chromosomal mutation, which is the change in the chromosome structure. And so now I would like to go into another type of chromosomal mutation, which is the change in the chromosomal number. The change in the chromosomal number refers to a change that involves the number of a particular type of chromosome, or maybe the change that involves the number of a whole set of chromosomes. This is due to some errors that might occur during meiosis, and the main factor is a phenomenon called Nondisjunction. We should know that during meiosis, homologous chromosomes should separate and move to opposite poles, like this. However, when Nondisjunction occurs during meiosis 1 or during anaphase 1, the homologous chromosomes will not be able to separate. And sometimes, Nondisjunction may occur during meiosis 2, in which sister chromatids will not be able to separate and move to opposite poles. And so now we know that Nondisjunction is the main factor that causes the change in the chromosomal number. And there are two types of the change. Number one will be aneuploidy. Aneuploidy will be a type of change in the chromosomal number, but it involves only one particular type of chromosome. While the second one will be euploidy, and we can also focus on the polyploidy, in which this type of change will involve a whole set of chromosomes. So now we will focus on the aneuploidy. This is a condition where a diploid cell, which is 2N, will be having less one chromosome or maybe having one extra chromosome. This is due to Nondisjunction that occurs on a particular type of chromosome that may occur during the spermatogenesis in the males or oogenesis in the females. Spermatogenesis is the production of the male gametes or the sperm. Meanwhile, oogenesis will be the production of the female gamete or the ovum. Let's say we have a cell which is a diploid cell, 2N, and we focus on one pair of homologous chromosomes over here. Okay, so Nondisjunction may occur during meiosis 1, in which the two homologous chromosomes will not be able to separate, like this. And sometimes Nondisjunction will occur during meiosis 2, in which sister chromatids will not be able to separate. And as a result, abnormal gametes will be produced. A normal gamete should be like this, and this one. This will be two normal gametes as they are in a haploid condition, N. However, due to Nondisjunction, sometimes abnormal gametes will be produced, in which we can see the production of N plus 1 gametes over here. This is the gamete that will be having one extra chromosome. And sometimes we'll be getting abnormal gametes like this, N minus 1, in which these abnormal gametes will be having less one chromosome. And when these abnormal gametes undergoes the process of fertilization, the case of aneuploidy will occur. So, there are two types of aneuploidy that we need to know. The first type will be known as monosomy, and the second one will be trisomy. Monosomy is a condition when a diploid cell or when an organism is having less one chromosome. Let's say we have a diploid cell and we focus on a pair of homologous chromosomes over here. This cell will undergo the process of meiosis 1. Unfortunately, Nondisjunction occurs during meiosis 1. As a result, both of these homologous chromosomes fail to separate and they will move into one same cell, like this. Let's focus on this cell. This cell will proceed with meiosis 2, and as a result, an abnormal gamete with less one chromosome will be produced. If this abnormal gamete, which is N-1 gamete, fertilized with a normal gamete, which is haploid, this will produce an abnormal zygote. This abnormal zygote will be considered as a 2N-1 zygote because this zygote will be having less one chromosome than it should be. And so for the humans, we should know that there will be 46 chromosomes altogether. However, in the case of an abnormal human, showing the case of monosomy, the individual will be having less one chromosome, and so the total number of chromosomes in the individual will be only 45. Now, what about trisomy? Trisomy is a condition when a diploid cell or an organism is having one extra chromosome. This will occur when an abnormal gamete with one extra chromosome or the N+1 gamete fertilized with a normal gamete. Let's say we start with a diploid cell again, and due to non-disjunction that occurs during meiosis 1, we will be getting a cell with both of the homologous pair since they are unable to separate during meiosis 1. So let's focus on this abnormal cell. This cell will then proceed with meiosis 2, and as a result, an abnormal gamete will be produced. The abnormal gamete will be having one extra chromosome. And when this abnormal gamete fertilized with a normal gamete, which is haploid, an abnormal zygote will be formed. This abnormal zygote will be considered as a 2N+1 zygote since it will be having one extra chromosome. For the humans, the abnormal human that is showing trisomy will be having 47 chromosomes altogether. An example of disorder that is caused by aneuploidy will be the Down syndrome. This is due to the non-disjunction that occurs on the chromosome number 21, in which abnormal gamete with an extra chromosome 21 will be produced. This is a diagram that shows the process of gametogenesis in a female, also known as the oogenesis, where something wrong happens during the meiosis number 1, in which non-disjunction occurs on the chromosome number 21, in which we can see here that both of these homologous pair for the chromosome 21 fail to separate, and both of the homologous chromosome 21 will go into one same cell. As a result, after meiosis 2 has occurred, an abnormal ovum will be produced, in which the abnormal ovum will be having 2 copies of chromosome 21. This abnormal ovum with 2 copies of chromosome 21 will fertilize with a normal sperm having only 1 copy of chromosome 21, and as a result, an abnormal zygote will be produced, in which the zygote will be having 3 copies of chromosome number 21. And this zygote will then develop and grow to become an individual with 47 chromosomes altogether. And the individual will be showing the Down syndrome. This is a karyotype which shows all the chromosomes for an individual. And from this karyotype, we'll be able to see that this individual will be having the Down syndrome because this individual is having 3 copies of chromosome number 21 over here. As a result, this individual with the Down syndrome will be showing some type of unique phenotypes. For example, the individual will be showing a characteristic facial features. Normally, the individual will be short in stature. There will be heart problems for the individual, and usually the individual with the Down syndrome will be showing some developmental delays, physically or mentally. Non-disjunction may also occur on the sex chromosomes, in which when the non-disjunction occurs during spermatogenesis, this will produce abnormal gametes, maybe with the chromosomes X and Y, or maybe with 2 X chromosomes, or maybe with 2 Y chromosomes. And if the nondisjunction occurs during oogenesis, this may produce abnormal gamete, maybe without any sex chromosome or any X chromosome, or maybe the abnormal gamete will be having 2 X chromosomes. If an abnormal sperm with 2 sex chromosomes, the X and the Y chromosomes, fertilize with a normal ovum with the X chromosome, this will produce the KLINEFELTER syndrome, in which the individual will be having 3 sex chromosomes, the chromosome X, another chromosome X, and also 1 chromosome Y. The KLINEFELTER syndrome can also be produced if an abnormal ovum with 2 X chromosomes fertilized with a normal sperm with Y chromosome. This diagram shows the nondisjunction that might occur during spermatogenesis in the males, in which abnormal sperm will be produced, and this abnormal sperm is having 22 autosomes, but this sperm is also having 2 sex chromosomes, both X and Y chromosomes. When this abnormal sperm fertilized with a normal ovum, let's say containing 1 X chromosome, this will produce an abnormal zygote with 3 sex chromosomes, X, X, and also Y. So this zygote will then develop to become an individual showing the KLINEFELTER syndrome. Individuals with KLINEFELTER syndrome can also be produced due to nondisjunction that might occur during oogenesis. When an abnormal ovum with 2 X chromosomes fertilized with a normal sperm with the Y chromosome, this will produce an abnormal zygote, again with 2 X chromosomes and Y chromosome over here. And so, if we look at the karyotype of an individual having the KLINEFELTER syndrome, we will be able to see that all the types of chromosomes will be having 2 copies, except for the sex chromosome, in which we can see here that there will be 3 copies of sex chromosomes, and the sex chromosomes will be the X, X, and also the Y chromosomes. And so the total number of the chromosomes for this KLINEFELTER individual will be 47. We can say that this individual is showing the case of trisomy 2n+1. And the KLINEFELTER individuals will usually show this type of phenotypes, in which they will be having an abnormal small underdeveloped testis, and due to the underdeveloped testis, these individuals will be sterile, meaning that they won't be able to produce any sperm, and they will be having some feminine secondary characteristics such as an enlarged breast tissue. Another case of aneuploidy which occurs on the sex chromosome will be the Turner syndrome. This occurs if nondisjunction occurs and an abnormal ovum with no X chromosome at all fertilized with a normal sperm with the chromosome X. As you can see in this diagram, when the nondisjunction occurs during oogenesis, an abnormal ovum with no sex chromosome at all will be produced, and this abnormal ovum might fertilize with a normal sperm having the X chromosome. As a result, an abnormal zygote with only 1 X chromosome will be produced, and this zygote will be developed and grow to become an individual showing the Turner syndrome. Individual with Turner syndrome will be a female, and this female will be having only 1 X chromosome, and we can say that this female is also showing the case of MONOSOMY X or XO, in which if we look at the karyotype for this individual, we'll be able to see that all the types of chromosome will be having 2 copies, except for the sex chromosome, in which there will be only one sex chromosome, and the sex chromosome will be the chromosome X. And the total number of chromosomes for this individual will be only 45. And so this is the case of 2n-1, or the case of monosomy. This individual will be sterile because they will be having underdeveloped ovary. Other than that, this individual will be short, they will be having poorly developed breasts, and they will be having webbed neck like this.